Hello students, welcome back to my channel. In this video, today we are going to learn Gibbs and Helmholtz free energies, which is a very important topic in thermodynamics. Okay students, in the last video we completed Carnot cycle, efficiency and Carnot's theorem. There we have seen how heat can be converted into maximum work. Okay, so this video I am going to explain a very important topic. So please take your notebook students and put the side heading Gibbs and Helmholtz free energies, which can also be called as work function and free energy function. Okay, so you can be like the question can be like this: explain work function and free energy function, or explain Gibbs and Helmholtz free energies. The same answer you are supposed to write. Okay, now, so what is this work function and what is this free energy function? Students, in thermodynamics, we have learned about many quantities like internal energy, heat, enthalpy or heat content, entropy. So like this, various thermodynamic quantities we have learned. Okay, now these, in addition to these thermodynamic quantities, there are two more quantities which we come across frequently in thermodynamics. Okay, so what are these two extra quantities which are frequently used in thermodynamics? One is work function, which is also called as Helmholtz free energy, and the other one is free energy function, which can also be called as Gibbs free energy function. So now you understood what is this work function. Work function also called as Helmholtz free energy, and free energy function also called as Gibbs free energy function. So that's what our topic is, Gibbs and Helmholtz free energies. Together, the work function and free energy function, it is given a common title, Gibbs and Helmholtz free energies. Okay, so in addition to various thermodynamic quantities like internal energy, heat, entropy and enthalpy, there are two more quantities which are frequently used. Write down. They are work function, which is also called as, look here, Mark. Are you able to see? Yes, they are work function, brackets write down, also called Helmholtz free energy, and free energy function, brackets write down, also called Gibbs free energy function. Okay, now let us learn individually first what work function is, then we will go to free energy function. Okay, so put the side heading number 1, work function, in the brackets Helmholtz free energy. Okay, so put the side heading and underline, students. So work function, it is denoted by the letter capital A, and it is given by the expression. What is the expression? Can you see in the video? Yes, A, work function denoted by the letter capital A. So A is equal to capital E minus capital T into capital S. Put it in a box and mark it as equation number 1. Okay, so work function, the thermodynamic quantity work function or Helmholtz free energy is denoted by the letter A, which is given by the expression A is equal to E minus Ts. Now tell me, what is A? Yes, now you know that it is work function. What is E? This we have already seen in the previous classes. Internal energy. T, you all know it is temperature. And yes, also you know it is entropy. In the recent classes, we have learned what entropy is. Okay, so A is equal to E minus Ts. Completed, ma? Written? So work function is denoted by the letter A, given by the expression A is equal to E minus Ts. Mark it as equation number 1 and write down the terms A, work function, E, internal energy, T, temperature, and S, entropy. Now, A is equal to E minus Ts. Remember this expression. So, students, in the expression of A, that is Helmholtz free energy, E and S, also T, they are the state functions of the system. You know what a state function is. Okay, we have already learned what a state function and what a path function is in the previous classes. Okay, so we have also seen that E, S, and also T, all these three in the above expression are state functions. Okay, so when all the three are state functions, automatically A also must be a state function. That's what I have written here. Since E and S in the above expression are state functions of the system, brackets mention T is also a state function, comma, A must also be a state function. Okay, so how will we know the importance of A? The importance or significance of A can be studied or can be understood by taking into consideration an isothermal change at temperature T from initial state to final state. That's what the definition of state function is. Okay, it's only about the change of the system from initial state to final state, but not on the path followed from initial state to final state. Okay, so the significance of A can be understood by considering, write down, hence the significance of A can be understood by considering an isothermal change, brackets at temperature T, of a system from initial state to final state. Written? Okay. So, below write down, according to equation 1. What is equation 1 ma? A is equal to E minus Ts. Okay. So, initial state, for initial state, the expression goes like this. A1 is equal to E1 minus Ts1. Mark it as equation A. For final state, the expression goes like this. A2 is equal to E2 minus Ts2. What are A1, E1 and S1? Below write down, where A1, E1, S1 are the values of work function, internal energy and entropy in the initial state. Okay, and now write down A2, E2, S2 are the values of work function, internal energy and entropy in which state? In final state. Very good. Now you are in the line. So following nicely Gibbs and Helmholtz free energies. Okay. So why did we consider initial state and final state? Because A must be a state function. Why A must be a state function? Because in the expression E, T and S, all three are state functions. Hence, A also should be a state function. So that's the reason we have considered the initial state and final state of the system. Okay. So for initial state, equation 1 we have written. For final state, equation 2, equation 1 for final state is A2 is equal to E2 minus Ts2. Okay, explain the terms. Write down the terms. A1, E1, S1 values in the initial state. A2, E2, S2 values in the final state. Okay, marked students. Equations A and B, did you mark? Okay, hope I have shown you the below sentence. Now below write down, subtracting equation A from equation B. Write down below equation A from equation B. If we subtract, what do we get? So how will you write equation A from equation B? So will you write A1 minus A2 or A2 minus A1? Subtracting 2 from 4. What will you write? 4 minus 2 or 2 minus 4? 4 minus 2. So here how will you start? A2 minus A1. So try writing ma. Then this step, subtracting equation A from equation B. How will you write? Left side you will write A2 minus A1 is equal to E1 minus TS1. Put it in brackets. Minus E2 minus TS2. Put it in brackets. So below, now remove the brackets. E2 minus TS2, E2 minus TS2 minus E1. When you are opening up the brackets, minus into minus plus TS1. Now bringing the same variables together, next step is equal to E2 minus E1, put it in brackets, minus TS2 plus TS1. Okay. Now below, left side mention A2 minus A1 is equal to right side E2 minus E1. Look here, minus TS2 plus TS1. What is common here? Capital T. So we can take a T common out. Now what will go inside the brackets? S2, S2. Here it will not come plus S1. You have taken T and you are now writing inside the brackets. So S2 minus S1. When you open up the brackets, you should get the same above step. Okay. Now A2 minus A1. This can be written as delta A. As we all know, E2 minus E1 delta E minus T into S2 minus S1 delta S. So delta A is equal to delta E minus T delta S. Put it in a box and mark it as equation number 2. Now what is delta A? What is delta E? What is delta S? Delta A is, what is A tell me? Work function. Delta A is change in work function. What is E? Internal energy. Delta E is change in internal energy. What is S? Entropy. What is delta S? Change in entropy. Okay. Now, suppose if the above change, see, we have started considering the change from initial state to final state. Okay. Now, the same change, if it is considered to be reversible, that means if the above change is taking reversibly at constant temperature. Below write down. Suppose the above change is considered to be reversible at constant temperature T. So, what is reversible taking place at constant temperature T means we can write it in a single term, that is isothermal reversible change. This also we have learned in the previous classes. That is isothermal reversible change, comma, what would be the amount of heat absorbed by the system? Then write down heat absorbed is equal to Q reversible. Why? Because we are considering that the change taking place reversibly. So the amount of heat we can denote it by Q reversible. And according to the definition, comma, according to definition, written ma, according to definition, comma, change in entropy. Change in entropy. How will you denote it with change in entropy? How will we denote? In the brackets, what will you write? Delta S. Write down. And according to definition, comma, change in entropy brackets, delta S is given by. Go back and check for the definition of entropy in the previous classes. Hope you have already learned. Because your exams are very close. Don't neglect. Don't waste your time. Change in entropy in the brackets, delta S is given by, write down, delta S is equal to Q reversible by T What is Q reversible? The amount of heat absorbed when the change is considered to be reversible at constant temperature. Okay. So according to definition, entropy, change in entropy, delta S is given by Q reversible by T. We all know from first law of thermodynamics, Q is equal to delta E plus W. Now, from this delta E, if I bring it to left side, is equal to right side. What do we write? Q minus W. Very good. Below, delta E is equal to, here Q is the amount of heat absorbed. So, how much did we consider? Amount of heat absorbed is Q reversible. Okay. So, write down delta E is equal to Q reversible minus W. Now, substituting the values of, we have students, look here, delta S is equal to Q reversible by T, delta E is equal to Q reversible minus W. Now we have the values of delta S and delta E in hand. So what do we do with these values? We substitute these values in equation 2. What is equation 2? Delta A is equal to delta E minus T delta S. Is it not the equation 2? Yes. So substituting the values of delta E and delta S in equation 2, we get, write down, left side delta A is equal to, in the place of delta E, what will you write? Q reversible minus W, put it in brackets, minus T is there, delta S value is Q reversible by T. So T gets cancelled. What remains? Delta A is equal to Q reversible minus W minus Q reversible. Again, substituting the values of delta E and delta S in equation 2. What is equation 2, ma? Delta A is equal to delta E minus T delta S. So, write down the value of delta E, write down the value of delta S. So, T into Q reversible by T. T and T gets cancelled. So, delta A is equal to Q reversible minus W minus Q reversible. So, Q reversible minus Q reversible both gets cancelled. So, what remains, ma? Delta A is equal to minus W. Minus W. Okay. So, now we considered that the change is taking place reversibly at constant temperature. So, for an isothermal, next below write down. For an isothermal reversible change, for an isothermal reversible process, W is considered as maximum work. So, we write it as W max. So, here we got it as delta A is equal to minus W. So, for an isothermal reversible change or for isothermal reversible process, W, how do we write, ma? It is considered to be maximum work. That is W max. So, delta A is equal to minus W will be written as delta A is equal to minus W max. Okay. So, bring minus sign to left side. So, minus delta A is equal to W max. Put it in a box and mark it as equation 3. Now, how do we put this equation in words? Or how can we put this equation expression in a statement? So, below write down. The above equation can be stated as follows. So, we have seen or we have considered the change taking place at constant temperature. So, below write down. For a process carried out at constant temperature, for a process carried out at constant temperature, put it in inverted commas, ma. For a process carried out at constant temperature, comma, so it is minus delta A, right? So, how do we put it in words? Decrease in work function, as it has negative sign. decrease in work function brackets minus delta A gives the maximum work done by the system. Gives the maximum work done by the system. Okay. So, this is the reason below. This is the reason why thermodynamic function A is called as work function. This is the reason why thermodynamic function brackets capital A is called as work function. Did you understand, ma? Why it is called as work function A? Because decrease in work function, it is giving us the maximum work done by the system. Hence, it is called as work function. Okay. So, this is the first thermodynamic quantity. Next, number 2. What is number 2? Put the side heading. Free energy function. Free energy function. Brackets. Gibbs free energy. Brackets. Gibbs free energy. Underline. Now, this will be very easy. Once we understood the work function, once we have studied the work function or Helmholtz free energy, automatically free energy function will be very, very easy to understand, students. We need not take that much stress or strain to understand this. Ready? Okay. Now, free energy function or Gibbs free energy is denoted by the letter G and is given by the expression G is equal to H minus Ts. So, work function or Helmholtz free energy, it is denoted by the letter A, whereas free energy function or Gibbs free energy is denoted by the letter G and is given by H minus Ts. Mark it as equation number 1. Now, tell me what is G? Free energy function. H, heat content or enthalpy. T, temperature. And S, entropy. Very good. Now, in the above expression, since H, S, T are state functions, G also must be a state function. Okay? H, S and T are state functions. G also must be a state function. For an isothermal process which is taking place at temperature T, for an isothermal process which is taking place at temperatures T, if the system changes from initial state to final state, how the expression, how equation 1 changes for initial state and for final state. Can you write down on your own, students? For an isothermal process taking place at temperature T, if the system undergoes change from initial state to final state, then G1 will be equal to H1 minus TS1. Mark it as equation A for initial state. What would be for final state? G2 is equal to H2 minus TS2, equation B. Same, below write down. Subtracting A from B. Subtracting A from B. How will you write, ma? G2 minus G1 is equal to H2 minus TS2, put it in brackets, minus H1 minus TS1, which is equal to, remove the brackets, H2 minus TS2 minus H1 plus TS1. Bringing the same variables together is equal to H2 minus H1, put it in brackets, minus TS2 plus TS1. Now, TS2 plus TS1, same like we did for work function, take T common out. So, write down G2 minus G1 is equal to, next step ma, G2 minus G1 is equal to H2 minus H1 minus T into, what will you write in the brackets? I am not showing the next step. After you write, I will show you. Then you can check whether you have written correct or not. T into S2 minus S1. Very good. T into S2 minus S1. Now G2 minus G1 can be written as delta G. H2 minus H1 can be written as delta H. S2 minus S1 can be written as delta S. So write down. Next step, delta G is equal to delta H minus T delta S. Put it in a box and mark it as equation number 2. Are you not finding it easy, students? Of course, yes. Right. Below, where delta G, delta H and delta S are change in functions. G, free energy, H, enthalpy, and S, entropy. Done. Next, below write down. If the above change is considered to take place at constant temperature reversibly. So, I have put it in simple sentence. For an isothermal reversible change, brackets, at constant temperature T, according to definition, delta S is given by Q reversible by T. So, we are not writing the amount of heat absorbed is considered to be Q reversible and all. Directly I have written, for an isothermal reversible change at constant temperature T, delta S is given by Q reversible by T. Here Q reversible is equal to cross multiplication T delta S. Now this, we know that, below write down, we know that delta H is equal to delta E plus P delta V. Delta H is equal to delta E plus P delta V. Now we have the values of T delta S and delta H. So these values can be substituted in equation 2. What is equation 2? Delta G is equal to delta H minus T delta S. See, here is equation 2. Seen? Okay. So, delta H value, delta E plus P delta V. Next, T delta S value we have Q reversible. So, substituting the values of T delta S and delta H in equation 2, we get can you see, students? Yes. Delta G is equal to delta E plus PdV, delta E plus P delta V minus Q reversible. Got it, ma? Substitution. How to substitute, you understood? Right. Now, below write down. Delta G is equal to delta E minus Q reversible. Put it in brackets plus PdV. Mark it as equation 3. Mark it as equation 3. Almost we are coming to the end of the answer, students. Below write down. According to first law of thermodynamics, for an isothermal reversible change, we know that delta E is equal to Q reversible minus W max. Okay. Now, bring Q reversible to left side. Delta E minus Q reversible is equal to minus W max. So what can we do with this delta E minus Q reversible value? We can substitute in equation 3. Look at equation 3. What is equation 3? Delta G is equal to delta E minus Q reversible. From first law of thermodynamics, for a reversible isothermal process, we got delta E minus Q reversible is equal to minus W max. Below write down. Substituting the value of delta E minus Q reversible in equation 3. Write down. How will you write? Delta G is equal to, now you need not write delta E minus Q reversible. We have its value as minus W max plus P delta V, which can be written as or bring that negative sign to left side. Minus delta G is equal to W max minus PdV. Okay, the same expression can be written like this. Both the values are same. Minus delta G is equal to W max minus P delta V. Mark it as equation number 4 and put it in a box. Now, how to put this expression in a statement or in words? Completed till here? Okay. Now, below write down. But, students, we know P delta V, what does it represent? It represents the work done in the expansion of a gas at constant pressure P. This already we have learned The same you are writing here, but P delta V represents work done in expansion of a gas at constant pressure P. Full stop. Thus, decrease in free energy. Minus delta G means decrease in free energy in a process taking place at constant temperature, and constant pressure will be equal to decrease in free energy in a process which is taking place at constant temperature and constant pressure is equal to maximum work that can be obtained from a system other than the work of expansion. Students, this is the meaning of minus delta G is equal to W max minus P delta V, which is equation 4. Decrease in free energy at constant temperature and constant pressure is equal to W max, that is maximum work, which can be obtained from a system other than the work of expansion. What is work of expansion? P delta V. Okay. Now, this is called as net work, not network. Don't mix, combine the two words, students. This is called as the net work. Underline. Below write down. Net work is equal to maximum work done minus work done during expansion. Maximum work done minus work done during expansion. It is equal to W minus P delta V, or W max minus P delta V, which is equal to minus delta G. Minus delta G. Okay. So, draw a line till here, students. Draw a line till here. So write carefully all the points in your notebook so that you may not miss any of the sentence or any of the line, any expression, or nowhere you will miss. Okay, so this is all for today's video, students. What did we learn today? Work function and free energy function. So work function is also called as Helmholtz. Free energy, which is denoted by the letter A, and free energy function, which is also called as Gibbs free energy, denoted by the letter G. Okay, students. So hope you have understood. So read. I always say this. Read twice or thrice. Practice it and also write without seeing. Then you will be very confident of the topic. Without any doubt, you can understand, and also while writing in the exam, it will be very, very easy for you students. Okay, so we will meet you. We'll meet you in the next video with a new topic, students. Until then, stay safe and take care. Thank you all for watching.